Hello my wisdom freaks, today you will learn about electromagnetism. Electromagnetism is a fundamental force of nature that governs the behavior of electrically charged particles. It's a fascinating field of physics that describes how electric and magnetic fields interact with each other and with charged particles, ultimately shaping the behavior of matter and light. Let's dive into the intricacies of electromagnetism. Electric charges. 1. Everything in the universe is made up of atoms, which consist of protons, positively charged, neutrons, neutral, and electrons, negatively charged. 2. Electric charge is a fundamental property of matter, and particles with the same charge repel each other, while particles with opposite charges attract. Coulomb's law. 1. Coulomb's law describes the force between two charged particles. 1. It states that the force is directly proportional to the product of the charges and inversely proportional to the square of the distance between them. 2. Mathematically, Fashe Q1 Q2 R2 R2 Q1 Q2, where FF is the force, KK is Coulomb's constant, Q1 Q1 and Q2 Q2 are the charges, and RRR is the distance between them. Electric field. An electric field surrounds charged particles and exerts a force on any other charged particle placed within it. The electric field strength, E, at a point is defined as the force experienced by a unit positive charge placed at that point. 3. Mathematically, EFQ equaf, where FF is the force and QQ is the charge. Gauss's law. Gauss's law relates the electric flux through a closed surface to the total charge enclosed by the surface. It states that the electric flux through a closed surface is proportional to the total charge enclosed by the surface. Mathematically, pH quencio pH iso kenk, where pH is the electric flux, kenquance is the enclosed charge, and 0 sense is the permittivity of free space. Electric potential. Electric potential or voltage is the amount of work needed to move a unit positive charge from one point to another in an electric field. It's a scalar quantity and is measured in volts, V. Mathematically, electric potential, VV, is given by vacuum VQW, where WW is the work done and QQ is the charge. Capacitance. Capacitance is a measure of a capacitor's ability to store electric charge per unit voltage. It's defined as the ratio of the charge stored on one of the plates of a capacitor to the voltage across the capacitor. Mathematically, capacitance, CC, is given by CAQVC-VQ, where QQ is the charge and VV is the voltage. Magnetism. Magnetism arises from the movement of electric charges. Moving charges create magnetic fields, and magnetic fields exert forces on moving charges. The strength and direction of a magnetic field at any point are described by magnetic field lines. Magnetic field. A magnetic field surrounds a magnet or a current-carrying conductor and exerts a force on any other magnet or current-carrying conductor placed within it. The strength of the magnetic field, BB, at a point is measured in Tesla's T. Amperes law. Amperes law relates the magnetic field around a closed loop to the electric current passing through the loop. It states that the line integral of the magnetic field around a closed loop is proportional to the current passing through the loop. Mathematically, bilocedience BDLMO ions, where 0MO is the permeability of free space and ENscience is the enclosed current. Faraday's law. Faraday's law of electromagnetic induction describes how a changing magnetic field induces an electromotive force, EMF, in a conductor. It states that the induced EMF is proportional to the rate of change of the magnetic flux through a loop of wire. Mathematically, AdPHDTE, DdPH, where E is the induced EMF and PHPH is the magnetic flux. Maxwell's equations. Maxwell's equations are a set of 4 fundamental equations that describe how electric and magnetic fields interact. They unify electricity and magnetism into a single theory of electromagnetism, showing that electric and magnetic fields are 2 aspects of the same phenomenon. The equations include Gauss's law for electricity, Gauss's law for magnetism, Faraday's law of electromagnetic induction, and Ampere's law with Maxwell's correction. Understanding electromagnetism requires a deep dive into these concepts, which are the foundation of much of modern physics and technology. From the behavior of subatomic particles to the functioning of everyday electronic devices, electromagnetism shapes our understanding of the universe and drives technological advancements. Thanks for tuning in to explore the fascinating world of electromagnetism with me. Don't forget to subscribe for more electrifying content and stay charged up for our next adventure together.